This video is to help you review how to analyze a set of data and to determine the relationship that exists between variables. Let's take a look at a set of data from which a student was trying to determine the density of an unknown substance. To determine the density, the student measured the volume and mass of several different samples of that substance. When you look at a data set, you should be able to determine what the independent and the dependent variables are. In this case, it's easy to do that because the graph is already set up for you. Independent variables are the variables listed on the x-axis. Dependent variables are the variables listed on the y-axis. Next thing you should be able to do is to plot the data. And if you need any help in doing this, please let me know in class. I'm going to plot the data rather quickly to save some time. When we're plotting data, we always want to be sure that we are using pencil because it's very easy to make a mistake. Once all the data points are plotted, you want to draw the line of best fit. That's the line that travels through all the data points as best as it can. And when we draw that line of best fit, in this case we see that that is a linear relationship. We get a straight line with a positive slope. Next thing you should be able to do is to calculate the slope of that line. And if you remember from your algebra class, slope is represented by m. And to determine slope, one thing you've been taught in the past is to calculate the rise over the run. Well, what that really means is that you subtract two y data points, and then you divide that by the difference between the two x data points. So this is the slope, this is the equation for finding slope, y2 minus y1 all over x2 minus x1. And we can do this from the graph, or we could do this from the data table. And to save some time, we're just going to take a look at two data points from the data table and plug those into our equation. Remember that mass is on the y-axis and volume is on the x-axis. So we're going to take the 2 points that we have chosen. We'll call this point 1, point 2, and the same thing for the x value. Oops, that's 1. And that's 2. And we're just going to plug into this equation. So y2 is 10 minus y1 all over x2 minus x1. We're just going to simplify this. 10 minus 2 is 8. 5 minus 1 is 4. Continuing to simplify this, we find that this line has a slope of 1. Now what we really want to stress is that slope has meaning. And the meaning of this slope for this particular data set is density, because what we essentially did is took y divided by x, which you guys should recall from last semester. Y divided by x, or in this case mass divided by volume, is density. So this slope actually has a unit. It's the mass unit divided by the volume unit. So the line is the slope. The slope of the line is the density of the substance in this particular data set. Let's take a look at some other things we can find from the data once it's plotted. You can also find the y-intercept. And remember, the y-intercept is the x value where y equals 1. Well, in this case, the y-intercept is 0. Remember, the y-intercept is also represented by the letter b. But in this case, it's 0, the value, because when the volume is 0, the mass is 0. You can't have a mass of a substance that doesn't exist. Well, notice what we have now. We have the slope. We have the y-intercept. What we can do now is we can translate that information into the slope-intercept formula. In math class, the slope-intercept formula is y equals mx plus b. Sometimes we just call this the linear equation. Well, what we can do is we can actually translate and put our values from our data set into this slope-intercept formula. So what I mean by that is you look at, well, what's on the y-axis? Well, what's on the y-axis in this case is mass. M is slope, and we just found out that the slope of the substance, the density of the substance is 2. X-axis is represented by volume. And there is no y-intercept, so we can actually leave that off. So what we get should be a formula that looks kind of familiar, is that mass of a substance is found by taking the density times the volume. And if you want to abbreviate these in your notes, you can. I'm just going to leave them written out so we can understand this. So we've taken a set of data, we've plotted it, and we found the relationship. We found that there's a linear relationship between volume and mass. We translated that into the slope-intercept formula. So any set of data can be translated into a mathematical formula. Once we have that mathematical formula that represents that data set, well, what we can do now is we can answer some questions. We can go beyond the data that we were given and determine different values for the variables. So let's do this one. Question 1. What would the mass of a 20 cubic centimeter piece of this substance be? Well, what we do is we take our formula, that I'll highlight one more time. We'll take this formula and all we simply have to do is plug into it. So we're trying to find the mass. We know the slope or the density times the volume. Well, this is the volume, it's cubic centimeter. So we multiply that right there. When I tried to pick some easy numbers, so the mass of this sample would be 2 times 20, which is 40 grams. You might want to pause the video so you can write that answer down in your notes because we will talk about it in class next time I see you. Let's do another example where we're extending this formula, the slope-intercept formula. What would the volume be of a 30-gram sample of this substance? Well, this time we're given the mass, so the mass is 30. We still know the slope or the density is 2, and now we're trying to solve for the volume. We're trying to solve for V, or volume. Well, what we need to do is we need to get that volume variable by itself. So what we want to do is we want to divide both sides by 2 so that the 2's cancel out, and we're left with 30 over 2 equals the volume. And we never leave answers in fractions in science class, so we want to simplify this. 30 divided by 2 is 15. And because that's volume, it has a unit that goes with it. So cubic centimeters is equal to the volume. Again, make sure you pause the video so you can write down the answers to these two problems and bring any questions that you have next time to class.